Okay, in this video, we are going to look at factoring by the difference of two squares. Okay, so the difference of two squares really is exactly what you read. It's the difference, which is subtracting, of two square numbers. So for example, I have x squared is a square number, and I want the difference of that and 16. So x squared minus 16 could also be written as x squared minus 4 squared, which just is another square. So I have the difference of two squares. So we're going to look at what happens when we factor this type of quadratic expression. So notice that my a value is 1, so I have x squared. My b value is 0, so these two numbers need to add to equal 0. And my c value is negative 16. So now I know that these two values will need to multiply to equal negative 16 and add to equal 0. Okay, so to multiply to equal negative 16 and add to equal 0, I have 8 times 2, but that would not equal 0. 4 and negative 4, that would equal 0. So I have 4x and negative 4x. So finding my factors now, I should have x to make x squared. I should have 4 to make 4x, and I should have negative 4 to make negative 4x and negative 16. So to write these as factors, I have x plus 4 and x minus 4. Okay, so we're going to look at one more to show you that this pattern will work for any difference of two squares and how we can use this to benefit us. So let's look at one more, and you can kind of write down what you see and notice about those. So again, we're looking at the difference of two squares. So let's try another one. Let's try x squared minus 25. Again, I have a difference. And they're both squares. So this can be rewritten as x squared minus 5 squared. Okay, so let's look at what that would be. So again, factoring, I have x squared. We know this will be negative 25. So these are going to make 0. So hopefully you've picked up on that this would need to be 5x and negative 5x to make 0 and multiply to equal negative 25. So this will be x and x. This will need to be negative 5. And this will need to be 5. So I have x minus 5 and x plus 5. So you can see that this is pretty efficient to factor the way we were factoring before, except if you start to pick up on this pattern, what you're noticing is I am just taking my square value, and one of them I'm subtracting and one of them's adding. So I can actually use a formula that can be found on your formula chart, where I'm going to take x sorry, let me fix that. On your formula chart, what you'll find, and I've actually brought that up here, is this difference of squares. So if I have something like a squared minus b squared, which we can see is modeled here. So if I have a squared minus b squared, a value that is a square minus a value that is a square, I can use this formula that will always be true. Okay, and my formula that will always be true is I'm going to have a minus b times a plus b. Of course, we know that we can write it as a plus b times a minus b as well, that it doesn't matter which order we write our factors in. But this is kind of a pattern we can notice and we can use when we are trying to factor values. Now, remember, it's not going to work for everything. So it really is a pattern that you have to recognize, and it is a formula that you have to understand. It has to be a difference. It can't be a sum. So that's important to notice.